Hi, my name is Sarah Springer, and I'm going to be talking about my practicum, where I help to conduct life history research on Hawaiian reef fish with a focus on Caranx ignobilis. I did my practicum with Poseidon Fisheries Research, participating in their biosampling program on HPU's Makapu'u campus. Through this program, we examined the life history traits of several commercially and recreationally fished species around Hawaii. Because coral reef fisheries are so biodiverse, there is a lack of data on some of the most commonly caught species. The biosampling program provides key data to the local fishing community, which includes the age and length of maturity and the maximum age of each species. Poseidon Fisheries Research conducts research on a number of valuable species, including Monotaxis grandoculus, known locally as the mu, Nassoliteratus, known as Uma, Caranx melampygus, known as omilu, and the fish that I focus on, Caranx ignobilis, known locally as Ulua alkea or white ulua. Most fish come from markets, but most Caranx ignobilis samples come from tournaments and donations from fishermen. We took the weight and length of each fish, then dissected them for the sagittal otoliths and gonads. Otoliths, or the ear bones, are one of the most common means of aging fish. On the top is a whole Caranx ignobilis otolith with a dime per scale. Calcareous material is deposited regularly through a fish's life, and once you take a thin section of the otolith, the bands of that deposition, known as annually, can be counted to obtain its age, similar to tree rings. The adult fish that we studied deposited annually on a yearly basis, so each band is 1 year. The bottom shows an otolith section of that same Caranx ignobilis otolith. And this picture shows, again, that same section, but with the annually marked with blue dots. This example shows a 22-year-old individual, though our project has shown a maximum age of 31 years. For the age and length at maturity, which is when 50% of the population is reproductively mature, known as A50 or L50 respectively, we look at the gonads of the fish. Males are denoted as either mature or immature based on the presence or absence of spermatozoa, while females are classified as immature, developing, spawning capable, actively spawning, regressing, or regenerating. Spawning capable and beyond are mature. This photo is of a donated female fish with 4 pounds of eggs. The age and length at maturity for males are 2.8 years and 465 millimeters. For females, the age and length at maturity are 4.4 years and 594 millimeters. While the life history data is interesting on its own, the importance of it shines through when discussing the current fishery regulations in place for Caranx ignobilis. The legal minimum size for Caranx ignobilis is 10 inches for home consumption and 16 inches for sale, and bag limits allow 20 fish to be caught per day. Caranx ignobilis typically recruits into the fishery around 9 inches, but the L50 for males is 465 millimeters or 18 inches. The L50 for females is 594 millimeters or 23 inches. The legal minimum means that more recruits will be available, but it also means that fewer spawning fish will be available as they reach maturity well after 10 or 16 inches. This is a photo of 2 papillo, or young trevallies that are less than 10 pounds. Further, Caranx ignobilis is at risk of overfishing or may currently be overfished. A common sustainable fishing rate of 30% leaves 30% or more of the spawning population. For Caranx ignobilis, the fishing rate is 28%, or 28% of the spawning population left, which means its fishing pressure may be higher than the fishery can sustain. This is common in species with a long lifespan, or species that are highly targeted, or both, which makes them vulnerable to overfishing. To bring it all together, we must bridge the gaps between fishermen and scientists, and Poseidon Fisheries Research does this by building trust with the fishing community and by getting valuable data from them. Data like this, the fishing pressure, the age at maturity, the maximum lifespans, all go out to the fishermen, often on social media. Fishermen who donate especially long-lived fish are given a shout out on social media, a great example of the transparency and collaborative nature of this project. The theory of our work has practical applications when used to recommend best fishing practices and guidelines, and highlights the importance of working with the community that will be most affected by these practices and guidelines. Through this project, I've learned how to obtain life history data and relate it to fishery management, but I've also learned that I really enjoy this work. I'm very interested in pursuing a career doing similar work, as I have found it all to be very rewarding, both the biology and working closely with the community to develop effective management strategies. Finally, I'd like to thank the Poseidon Fisheries Research founders, John Wiley and Cassie Pardee, for being wonderful mentors through this entire project, and my practicum advisor, Dr. Olivia Nigro, through Hawaii Pacific University. And I'd like to thank you for watching, and I hope you enjoyed.